All right, here now we are going to discuss the lateral directional modes. Lateral directional. Lateral directional modes means very simple. If you have lateral, it means rolling will be there. If you have directional, yawing will be there. Okay. So if you are combining both, it means both. So basically, this mode is what involve rolling and yawing, movements. If you talk about the lateral directional modes, it means here rolling and yawing movements is what right. Now coming to the different three important dynamic motion. This will basically these two moments will basically rise. This two moments rolling and yawing combined, and it will rise three important dynamic motion. Okay? Three important dynamic three important dynamic. What are the three dynamic important motion? The important dynamic motion are is nothing but is nothing but directional divergence, directional divergence, and another is nothing but spiral divergence, spiral divergence. The third one is nothing but Dutch roll. All three are very Dutch roll. All three are very important. Now, first we'll talk about the spiral divergence. Okay, first we'll talk about the spiral divergence. Anyone you can. We'll talk about the spiral divergence. First one, spiral divergence. As I told you, we are combined both lateral and directional, and both you are going to discuss here lateral and directional. So in lateral, what we have a roll, directional we have a yaw. So when this spiral divergence may occur, this is important. You need to do. You just remember this. When the aircraft, 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 aircraft too much directionally stable, too much directionally stable, and and point one and and too little lateral laterally. So very important. Our overall conclusion we got here. Once spiral divergence is what coming objective question asking. Once spiral divergence is not coming, these 2 points you need to solve. What are these 2 points? 2 point is uh, directionally it is uh, stable, and 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 laterally laterally stable, very much, very less. That's all. So what will happen in this situation? Suppose disturbance came and hit to the airplane. So if the airplane is what directionally too much stable, too much stable, so definitely once disturbance comes and disturbance in your to starboard, it will try to rotate. It will try to yaw the starboard, means the airplane will move towards the starboard. Okay, and because it is too much directionally stable, so what it will try to do, it will try to quickly eliminate the motion, yaw motion, whatever the yaw motion occur because of the disturbance. If it is much more stronger directionally, then it will try to eliminate that motion. It will come back to its original position. That's the mean of it. Okay, but at the same time, I told you once yaw will be there, then roll will be there. So the rolling moment to starboard will also be created. Okay, just before only I had told you, they understood. So now based on this analysis, what will be the motion of the airplane? So that motion will be the spiral divergence, and that motion will be uh, completely changed the path, completely change the attitude of the airplane, completely change the attitude of the airplane also. Okay, now, so here just see the motion. Basically, a rolling moment to starboard will also be created, causing the aircraft to roll to starboard, and consequently it will lose height as a result of tilting the lift vector. Because of the rolling only, I told you once rolling will be there, lift vector will be tilted. Just now here I have shown you, once rolling will be there, the lift vector will be tilted here. Okay, lift vector will be tilted here, so it will lose the lift. And once there is the loss of lift, then what will happen? The airplane will lose the height. Always remember, this is very important. In this case, always there is the lose of height. Lose of height. Okay, lose of height. Once you will talk about the uh sorry, here I should not write, I think I have to write here. So once spiral divergence will come into picture, always remember, because this is the 1 marks question. Okay, so you need to remember, once spiral divergence will be there, then there is the loss of altitude. Why there is the loss of altitude? Because rolling will be there, and once rolling comes, then lift vector will be tilted, and once lift vector will be tilted, so the amount of lift that will be decreases. Okay, because L cost component will come with the lift, and obviously that value will be less. Okay, that value will be less. That you know very well. What is the lift vector? Generally, here we have to take uh, L cost component. If you remember, turning flight I have told. So because of this lift, now here it is L, and this is L cos phi. Phi is what somewhat around 5 degrees, 6 degree, 10 degrees. So definitely L cos phi will be less than L, right? So means lift is what now decreases. Once lift is decreases, what will happen? That airplane will have loss of altitude. This is very, very important. You need to remember for the spiral divergence. Once the altitude is what decreasing, then the word you can use, the word is, the basically aircraft is now actually diving in. uh, Spiral dive, which is called spiral dive. Dive means that altitude is what continuously decreasing, so there is the spiral dive. Once loss of altitude is there, then there is the spiral dive. Spiral dive means it is continuously going down, 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 down. Because, and why it is happening, it is because of the insufficient lateral stability. Because this, everything is what happening because of this very less lateral stability, means insufficient lateral stability we have. Hence the plane is what continuously spiral diving, and this, the now this, the kind of instability is known as spiral divergence. This kind of instability called as spiral divergence. Okay, the kind of instability here, instability, instability is known as spiral divergence. So spiral divergence, what is the important point? I told you, in spiral divergence, yaw stability will be very strong, and lateral sorry, directional stability, which means yaw, will be very strong, but lateral stability, which is the role, which is very weak, actually it is insufficient. Hence the plane is losing the lift, and once loss of lift will be there, then it will be losing the altitude also at the same time. And due to this, the spiral diving will be there, and the this kind of instability, this kind of motion called as a spiral divergence. So I will show the actual diagram how it is happening, so it will be more clear to you once you see the diagram. Okay, generally this is the initial direction of flight. Here, this is what initial direction of flight, direction of flight. The flight supposed to go in this way. Okay, and where is the flight? Flight is somewhere here. This is the plane now. This is the plane now. The plane supposed to go in this way, but I told you it is laterally insufficient stable, and directionally it is much more strong. So once disturbance came and hit to the airplane, so the airplane will start motion in this, called spiral divergence. The airplane will move in this way, and it is moving something like this is called spiral divergence. Airplane will be, is coming like this. There is a loss of altitude. See, it was supposed to go in this way. It was supposed to go in this way, but it is not going in straight. Why? Because disturbance came and hit to the airplane, and this airplane was directionally so much stable. So once yaw came, and because of the disturbance, yaw motion will be there, but immediately it will regain its original position. But laterally it was not stable, so the plane is what rolled, and once it is rolling, then it is not able to come back to its original position. So once rolling will be there, then there is the lift component which is changed. Once rolling will be there, suppose this is the now roll motion, this is the roll motion, so lift component here, it is now changed. See what is the lift motion, lift for this. So I will show the uh, component of the lift. So obviously lift is now tilted. Once lift is what tilted, lift will come here. So the vertical component need to check, this is now phi banking angle, and this component will be L cos phi. So obviously L cos phi is less than L. So loss of lift. we have a loss of lift. Okay, once loss of lift is there, then we have a loss of altitude. So once loss of altitude is there, so this type of motion will come into picture, called a spiral divergence. Basically it's a motion when it is characterized by an aircraft that is very stable directionally but not very stable laterally. You need to remember this word. The spiral divergence will come. Spiral divergence come. Explain, I have written also, but again I'm writing in short. You need to remember because question will be asked based on. So aircraft.
सर मुझे पीपीटी नजर नहीं आ रहा सर.
What about others?
हाँ अभी अभी आया सर. आ रहा है सर.
Okay, so aircraft is very stable. Is very stable directionally. Again I'm writing directionally. Okay, not very stable laterally, but not very stable laterally. Need to remember. Okay, this is called spiral divergence. So many questions can be created here for single marks. So once I will conduct test, so obviously question will be asked, very basic question will be asked, and very important question will be asked related to GATE exam. All right, this is what is spiral divergence. Hope everybody understood. Now coming to the directional divergence, another motion. The first one, coming to the directional divergence. Directional divergence. What is the directional divergence? Now see. So if the plane is what, even though directionally it is not, if plane is what directionally not, we have to write. This will occur. Okay, this will occur when directionally unstable. Simple. When the airplane is what directionally unstable, then what will happen? Directional divergence motion. So if directionally it is not stable, then once any disturbance came into the airplane, so definitely your yawing moment will be there. Okay. So once yawing moment comes into picture, so yawing is what, just like a turning. I told you the airplane will turn towards the starboard. That is the yawing moment. But the airplane is what, turning towards starboard, and once it is directionally stable, then again it will come back to its original position. But suppose it is not stable, then what will happen? Simple, it will leave their original path, and there will be the displacement from the original path that will go somewhere other direction. Okay, and once aircraft is what going a straight flight, okay, then it will not be a straight flight now. There will be a small displacement in your to starboard, right? And it will leave the path only. Simple. So that displacement will continuous rise, continuous rise in displacement. Why? Because it will not try to come back to its original condition. Why? Because it is directionally unstable. I say directionally stable means the airplane is what, suppose turn towards starboard. Okay, the aircraft is what turns towards starboard, means towards right wing. All right, but once it is not directionally stable, then it will not try to come to its original condition. If it is turning towards starboard, it will turning will be continuous. It is going away uh, continuously from the original direction. Simple. So that flight path will be now continue to curve away from the original direction. So simple diagram I can show you. This condition, suppose we have here, uh, the plane is what now going. in this
सर
straight
ते
path.
किती मीटर निघालं सर फिर से सर